Okay.
It does disturb you, but expect that some people will come in. You already started. Oh, it's getting dark. Is this the sign to start if it's getting dark? Start. Okay, everyone. Welcome back. I'm going to start now because if not, we're going to have such a delay. Welcome back to the fifth session on ICT4S 23. It's an awesome session that awaits us with very diverse set of papers. We have one on Tech for Bad, based on a literature study. We have another literature study with regard to process mining and circular economy. We have two assessments. One is an LCA model, a new one for software. And last but definitely not least, actually it's the second presentation, is an input-output analysis on ICT on a global scale. So very interesting paper. And let's start with the first one. This is Ian from the University of East England, and it's done. The paper is written in collaboration, which I also really like, with KTH people. We are sitting here, and the paper is on Tech for Bad in the oil and gas industry, exploring choices for ICT professionals. Stage is yours.
Thank you very much, Steffi. We've had some great talks, haven't we? Wonderful papers about the impacts, life cycle impacts of IT. We've seen some great talks about the enabling effects of IT, things like carpooling, the ways in which we can make the world better with IT. But we also need to talk about the damage that IT is supporting. And particularly after that last keynote, how do you feel? How do you feel about working in the tech-related area? So I'm very pleased to present this paper, co-written with my colleagues Minna and Axel. Do stand up, let people see who you are so you can talk to us later. From KTH, so they're playing away for this game. They'll be playing at home next time. And if I can move on to the next one. Let's see.
Oh, just press here. Okay, we have issues.
Who would work with Apple products?
Yeah, no.
Like
No,
one.
this works. Yeah.
Great. Okay. So, yeah, we talk a lot about, we are ICT4S as a community, ICT for sustainability. If you look from a business perspective, they'll talk about this as being tech for good, and that's the framing, for sustainability, for good. But I think we really need to spend more time talking about tech for bad, the way in which tech enables damage to our society and damage to our environment. And with Minna and Axel, we wanted to look at a case study, oil and gas. The oil and gas industry is at the heart of the damage being done in climate change. Now, if you don't know the oil and gas sector, this is the way they talk about themselves. Upstream is exploring for oil and gas and pumping it out. Midstream is transportation and storage, and downstream is refining and selling the fuel. It's not actually a particularly heavy carbon industry in that. The damage is done when we burn the product. So if you're more familiar with an LCA or Greenhouse Gas Protocol way of thinking, actually the real downstream is when we burn the product, scope 3 as far as the industry is concerned, and that's where the damage is done. But still, these companies are the ones that are ultimately responsible for making that product. Fossil fuels contribute about 86% of anthropogenic greenhouse gas emissions, and they have to decline. This is an industry that has to end. Coal first, and we decided not to look at coal because there's fairly widespread agreement that coal has to be phased out. Oil and gas, perhaps less so. It still seems a very acceptable industry to many people, and I don't think this pace of change is accepted by many in the wider community. This is a report from the International Energy Agency, their net zero report, and you can see how rapid that decline is. Let's take a step back. Sustainability is a matter of values. Yes, there's science in things like climate science, but this is a lot a discipline about values. It's normative, and you probably ought to want to know who we are, who did this work. We come from a perspective that technology is not the primary solution. It really is about the need for change and transformation in society. You saw the three of us, we are Northern Europeans. We come from a privileged background of fossil fuel wealth. And two of us have worked for the oil and gas industry, or the fossil fuel sector. Minna worked with an energy company that burned coal. And in my management consultancy career, I helped implement SAP oil and gas systems that made Shell and BP more efficient. Feel free to boo and hiss now. And I deeply regret that. And I kind of wonder, why didn't I connect climate science with that work at the time I was doing it? There is a very particular culture within oil and gas. Making the world better for people, giving people energy and warmth. And if you're in the industry, it's kind of hard to listen to the voices outside. We're also, all three of us, PhD students, so we are relative novices in this group of people here today. But some of us have a bit of experience in other places. These are the research questions we pursued. We wanted to understand a bit more about this oil and gas space and the role of systems. How does ICT enable the damage? How many people are working in this sector? Do you know? Do you have any feel for that? What examples are there of ICT professionals already pushing for change? And how might we conceive of the ways in which ICT professionals could think? Now, this is not a completed systematic literature review. We have just done a scoping review. So this is presenting more of an agenda for research, but giving the reasons why we should pursue this. And the answer to research question one is, well, there's very little in the academic literature, but there's plenty in the grey literature and commercial literature. Businesses like SAP have made a lot of money providing end-to-end systems for the oil and gas industry. But let's not just call out SAP. Let's also talk about Microsoft, who have industry architectures for upstream and downstream oil and gas, or AWS running these services. So this damage, this product that changes the climate, is supported by ICT people. And perhaps we ought to consider stopping that. In fact, there was an IEA report in 2017 that said if you applied more digitalization upstream, you could extract 5% more of the oil. Doesn't sound very big, but hey, congratulations. We as an IT industry can help to add 10 years worth of production. I don't think we should be doing that. How many people do you think work in this sector? Well, we didn't find much in the way of detail, certainly no academic papers, but we did find an interview with the BP CIO. 10,500 IT people working just for them on oil and gas systems in 2015. So add Shell, Exxon, Aramco. This is a lot of people we're talking about who are in a declining industry, whether they know it yet or not. What examples of action are there already? Well, there is organizing. People in Google and Microsoft and Amazon have organized, have written letters to management, have partaken in climate strikes, but it's not had a huge impact yet. Pretty much business as usual. There's an interesting little example. We had the open source colleague this morning. Well, there's an open source license called the Climate Strike license. License your software under that, and it forbids fossil fuel businesses from using your software. Yeah, okay, I know. Try to enforce it. That could be interesting. There are much better examples of action in other professions or other issues. And in our paper, we have a table telling you more about each of these. So law students and indeed barristers in the UK are getting quite organized at not doing work for oil and gas companies. Marketing creatives are beginning to organize themselves. Shell is looking for a new marketing agency. There's a real campaign to stop agencies pitching to them. Tech Won't Build It is perhaps the most successful example, which led to Google not renewing the Project Maven contract with the DoD. What examples are there of how might we conceptualize, rather, the ways in which IT workers in oil and gas might think about their roles and about their future exit? Well, we might take a pragmatic self-interest perspective. These jobs pay pretty well at the moment. I can understand. And having worked in the sector, I also understand that it is exciting. You're at the heart of geopolitics. But the industry is coming to an end. And if your job is in upstream exploration, perhaps the geophysical systems, that job's coming to an end pretty soon. And you really need a plan to get out of there. Plan your exit now. We want to make sure that Just Transition is there for oil and gas workers, not just for everyone else in society. We might also wonder whether there are ethical ways of thinking that ICT staff could use. So professional ethics, BCS, ACM, Karlskrona Manifesto, the SDGs offer one potential ethical form. Secular ethics, we must talk about utilitarian versus duty-based deontological. And there are 5.8 billion people affiliated to Christian, Muslim, Hindu, or Buddhist religions, and some of those work in oil and gas, so maybe there is a religious ethic to be used. These are questions we'd like to test out in the research, because this is really an agenda. Do you choose to not work in the oil and gas sector? If you're in it, do you choose to challenge it from inside? We would like to run a research program, to do a proper systematic literature review, to look at the value chain and say which parts of it are going to stop first. Workforce data can we find on LinkedIn? And indeed, learning from history. The slavery business went from acceptable to unacceptable over quite a long period of time. What's it going to take for oil and gas to go the same way? How can we learn from historians? Hey, probably not easy to get this one funded. If you've got any ideas as to who we should approach to fund it, please do talk to us later. If you know people in this sector, what are you talking to them about? And that's it. Thank you very much.
Thank you, Ian. Interesting talk. Any questions? Yes. Daniel, and then back there. He was first.
Yes, so I'm Daniel Pargman from KTH in Stockholm. And your last slide said, now what?
Yeah.
Challenge the industry from within. And I read Andreas Malm's book last year, How to Blow Up a Pipeline, where he suggests we should sabotage oil infrastructure, oil and gas. So
he said some people might want to sabotage.
no, I just said what he wrote in his book. Yes, that was his suggestion. Because coal companies are still being built and they expect to be run for 50 years, so we should stop that, is his opinion. So you said challenge the industry from within. So now I'm asking you, does that include sabotage the industry from within?
That is not within the discussions that we've had. So, there was a question, in fact, you asked the question, what would your work be if it was more radical? And the logical extension of this work would be how to hack a pipeline. But I'm not there yet.
Thank you.
Hi, I'm Nicolas from the Disnovation Collective. I just had a sort of a feedback or anecdote to the idea that we need to decide to stop fossil fuel and sort of have the proper ethics and mental framework to go out of fossil fuel. But it seems like the analogy with slavery can maybe help us think differently. It's like many authors consider that slavery didn't really stop because of ethical framework, but because we got cheaper energy source at the same time. And that the cheap availability of fossil fuel was actually, or coal, was actually the accelerator of the transition.
That's a very good point. And I think it is too reductionist if we look for just one historical reason why it stopped. There are many. You can look at examples of ethical consumerism in the 19th century. Yes, that there was the revolution in Haiti, the Marron. So there are a number of reasons why it stopped. And what is our theory of change? We're not just pulling on one lever. I agree. We will look for replacement. We look for cheaper electric vehicles so that people will transition to those more attractive technologies. But we still need this industry to come to an end. And at the moment, it doesn't look like it plans to.
Thanks.
Another question? Here in the middle.
Aista from La Rochelle University. So I'm going to play a little bit a devil's advocate here. But first question, so if you reduce the number of people available or who want to work for the oil and gas industry, that probably is going to make the pay rise for those, since there is less of availability, there's going to be a more demand, and therefore already they're paid quite well, so it's going to, the salary is going to increase, and therefore there's always going to be somebody who will want to work, who's motivated by money, right? So that's number one. And then my question is, I guess currently you don't have a data, but maybe to look into that later on. I have no idea how important, you said there are 10,000 ICT workers in BP, right? But proportionally, is it 1% of their all workers' value? How much actually, if ICT good quality workers decide to stop working, so let's paraphrase a little bit, would that make actually a big difference within the company, or how much they depend on a good quality ICT infrastructure?
Okay, so question one. Yes, I understand the dynamics of labor demand, but actually the industry is going to decline rapidly, has to, and therefore will need fewer workers anyway. So I think that that's probably going to be countervailing forces. Second one, how significant are they? Well, these businesses rely upon their IT to operate, and they need quality people to make it work and continue to work. So it is essential to their business. They would find it very hard to operate without it. Take it to the panel.
Yeah. Okay, two more questions, that's it. There's the guy in green.
Okay, I start. It's kind of a geeky question, but did you try to estimate, let's say, the added emission due to ICT in the oil and gas industry? Because we like to talk about enabled emission, but enablement goes both ways. by avoiding emission, but also adding emission. So in that case, did you come up with some kind of estimate?
Not specifically, as I said, this is more of a scoping review, but I think that the oil and gas industry on this scale would not be able to operate without IT, so we almost enable all of it.
I think it's not available anymore, but there was a press release from Microsoft saying that thanks to the IT solution, they increased the barrel extraction in the Permian Basin by 50,000 barrels a day, directly due to the IT system. So you can come up with quick numbers with that.
Yes, the IEA 2017 report does give this indication of 5% extra production from IT-driven.
Okay. One last question, as I said, there was here in the... A quick one, please. Just one. Choose one.
Just a quick question. Some voices are arguing that developing countries, in particular African countries, should be allowed to extract their gas reserve. So, for example, Mary Robinson argued for that because you positioned yourself, which was really nice at the start. As Europeans, we benefited tremendously from the oil and gas industry. And nowadays, we're essentially saying the world has to stop. But some countries didn't extract as much or didn't benefit from it. And so there's a debate on these issues. What is your position on that?
My position is that for global justice, we need the developed world countries like the UK to stop earlier. I am deeply embarrassed that we're continuing to allow new exploration in the North Sea. But it is a very difficult conversation to have because it's also wrapped up with energy security. And papers by Kevin Anderson are quite good on this.
Thank you very much. Thank you, Ian. Thank you also for the question. So next is Francis from CITEPA. CITEPA, I hope I pronounced it correctly. It's about an input-output analysis on ICT emissions on a global scale. Yeah, no, need to move the...
Need to do some more.
I think we can't see it. Not gonna look.
Yeah.
No, we still can't see it. Can you start the presentation?
Okay, I think I need a technician. So,
Should we talk more about oil and gas?
Yeah, there was a question here, I think. Yeah, where we tried to figure this out.
okay, so what's happening?
Do you think that capitalism can be part of the issue there in what you've seen?
That's the point at which I say, I'm on IT, I'm going to stick to my lane. I am not yet at the point of saying that capitalism makes this impossible, but I'm quite close to that. I trace a lot of the ills of this to corporate structures and to limited liability. Is it possible to tame capitalism? I also think that, personally, because of the shortness of time for action, maybe we don't want to take on that huge task relating to capitalism. But that is one for a bigger, longer discussion, perhaps over the dinner this evening.
Okay, thank you. Can you just stay there
again.
If anything happens?
Thanks. Now the stage is yours.
Thank you, Stephanie. So I just put my counter here. So I really enjoyed the body language of friends of EcoInfo doing like that or like that. It's not easy to speak to you like that. So I use a body language maybe that was proposed by Birgit in a mail about a month ago, so I'll use a cap. And this is body language. This is a cap for emotion and opinions, maybe. And to say that I'm really happy to be able to talk to you physically. The first time I come to this conference physically. And I really tremble to speak in front of so many leading researchers in the area. So I take out this hat. And now, I'm going to talk about estimating the footprint of oil and, sorry, not oil and gas, but the ICT. And we first looked at a technical point, which was avoiding double counting. And then we saw we could apply this to a question like evaluating the global footprint of ICT. So if we look at the framework of methods available for doing that work, we have basically, here we start with physical measures there, and then traditionally for ICT, we have an intermediate step, which is LCA, and then we flow all the data the way to, then we go through LCA, and then the data flows to a work which is weighted inventories, and then we have the figure. Now, what we wanted to look at is we know that there's this second path available on the left-hand side, go through national statistics that are available on a yearly basis for all the countries, and then go to another type of method, which is input-output analysis. So we compare our results to reference studies, for instance, the reference studies of Malmodin and Lunden that are present in this room. That's why I tremble. And these May original studies, in-depth studies, I would say, in fact, they all follow, if I understand well, the weighted inventory approach that relies in turn on LCA. And there was a very interesting meta-study. I think one of the authors is here, Mrs. Widdicks, and it's the study in 2021 of Freitag et al. And they say that, in fact, they claim that these studies relying on weighted inventory are subject to an underestimation bias due to a technical problem, which is LCA cutoff. And they give an estimation for this underestimation. So what can input analysis help in doing in this problem? And a classical way of looking at IOA, input-output analysis, is big matrices, lots of numbers and matrices, vectors. And this is a little bit tedious, so let's look at it in a graphical view, through a graphical view. And it's much easier. So on the left-hand side here, we have a group of sectors. Typically, we worked on the OECD classification sectors into 44 sectors. And so you have a bunch of 44 sectors. They all interact between themselves, and they exchange commercial goods, of course. And they are all driven by the final demand, which is here on the right-hand side. And so the final demand of people like you and me, they issue requests for productions. And so let's look at final demand for products I. Let's picture it as a PC. So we need a certain quantity of PCs. We quantify it by a letter, a quantity DI. And so to produce these PCs, we need the industry I here, producing PCs, to produce a production of PCs, and which is larger than DI, because they have to produce PCs for the whole value chain of producing PCs. And by the way, it's not a value chain starting with a start and an end, it's a value network. So everybody's contributing to this value production. And input-output is a classical way of, so it's used generally to estimate the footprint of the final demand, and it's generally used for estimating the footprint of countries. And so we did this on the world scale using the data from OECD, and we arrived with this figure for the footprint of the final demand. Now, what about the industry? So it can be used, and it was foreseen 10 years ago, and thank you for the anonymous review who pointed out this to me 10 years ago, to estimate the production footprint of an economic sector, such as, well, it's well defined. The problem is that ICT, in this classification of 44 sectors, is a group of 4 sectors. And the classification is not good enough, so if you take those 4 sectors, it overstates ICT. So the problem we were trying to tackle was calculating the footprint of a group of 4 sectors. So IOA can be used to do that, and we made a calculation. We arrived to this figure. Now let's look at the numbers. So sorry, I had other hats to wear, but I'm too carried away. So this is a hat for applied reasoning. So you see here you have the 4 sectors that are relevant for ICT in the OECD classification. The first one is computers, electronic, optical products. And so if you add up the direct emissions here, you end up with a number here, which is, you can add it up, it's additive. You can do the same with final footprint here. You can add it up and you have this figure. But you can't do the same with production footprint. You cannot add up the figures for all the separate 4 sectors. So you have to retrieve the the double counting. And so we do this. And we find a double counting ratio about 7% in this case. And so we retrieve it and we have this figure, which is, by the way, too important if you compare it to the reference studies. So we looked into what was in these 4 sectors, and they were overstating ICT, so it was a larger scope than ICT, and we had to remove electronic components and remove a bunch of things. So in removing, we had a big approximation in doing this work. That's why the result of the removing is rather an interval here. Now, we remove it, we remove satellite networks, we remove a bunch of things, but we have to do something that IOA cannot do, which is estimate the use phase footprint for everything in the economic system that is not ICT sector. And so we looked at the paper from Malmodin and Lunden, and I figured out that maybe this figure was correct, so I add up this figure. And I obtained finally this range, which I compare to the range proposed by Freytag et al. And I find, oh, it's compatible. But it's rather in the high end of the range. And I think my time is over, so the conclusions are do we have yet another indicator or a family of indicators? There are still lots of approximations in this work. That's why I need to collaborate with people that can help me reduce these approximations. And it is best used if we can combine it with LCA work for the use phase. But the good thing about this is the data is open source. You all can use it. And the other thing is the method is simple. It's fully described in the paper. You can replicate these calculations and find all the bugs I made while I was doing them. So thank you for your attention.
Thank you very much for this very engaging presentation. I almost forgot the clock. Anyhow, I wonder which hat you're going to wear when you answer the question.
I have all my 3 hats.
Yes, good. Vlad.
Hi, thanks. This is my feeling rather stupid hat. If you go back to the last slide, what is the difference you had 3 categories of, So direct emissions, I think I can understand, but the difference between final demand and production footprint, I'm not entirely sure I got it.
Okay. Final demand is basically... Sorry. Okay, this is maybe a more theoretical hat. It's a nice Irish cap, by the way. You can buy it in France. And so final demand... You can calculate with these methods for each sector the footprint. It's an LCA approach, really, but applied to the economy. And 10 years ago, there was something called EIO LCA that was proposed. And it's because it's formally the same thing, but at a macroeconomic scale. And so you can compute the footprint of everything, of all the ICT purchased by people like you and me. And that's the first figure. And, but the thing is, production, and then it's also an LCA, but at a different point. Because the problem is we are in different points in the economy. Either you are located at the consumer point, or you are located at the production point. And if you locate there, you have a much larger fish. It's an LCA type of calculation, but it's much bigger because you have to produce all the ICT necessary for all the chain of value of the ICT. And it's not the same figure, obviously.
Yeah, so it's like the production versus consumption perspective?
Yes.
But in an input-output, okay, I didn't know that input-output allows
Well,
it.
there are lots of very neat methods using IONA, and for instance, for sharing responsibility between different producers. It could be used, I believe, for instance, okay, I'll talk about later, sorry.
There was another 2 questions. Sorry.
Okay, thank you for the talk. Just a quick technical question. For your work, you need to rely on macro-scale economic databases, and I'm just wondering which type of metric is used to define the DI parameter. Is it physical flux of computers, phones, or ICT devices, or is it determined based on economic fluxes?
That's
flows, sorry.
More for practical questions, and not dumb questions, but practical. So, very good question. The physical flux in traditional IOA is monetary value. That's one of its weaknesses. It's in LCA, it's physical units and all kinds of different physical units. So that's one of the weak points of it.
Thank you so much for a really interesting paper. I very much enjoyed that. One of the classical problems with EIO is that it is only cradle to gate to the production,
yes,
not cradle to grave. Do you think it has a useful role to play still, or is it an approach that's going to wither?
I think it's yet, so that's my opinion, Cap. I'm reading about a philosopher that says you have to know in what mode you're speaking. Is it an opinion or something else? No, I think there are some strengths because the data is available every year. And so you can do some partial analysis, but you can have a time series very easily. And but to have the best result, we should, I think, hybridize it, combine it to LCA. And by the way, in fact, both approaches, LCA and IOA, they strengthen each other. And this was one of the things of the paper by Freitag et al. And it's not the only paper about this.
Great, thank you.
So thank you very much. We need the hats then for the discussion, I think. So now to another very different topic again on business process mining, and it's presented by Nina, and she's coming from Aachen. Obviously, Will van der Aalst, who's kind of like the god of process mining, so I'm not surprised to seeing them here. And quickly over to you.
Yeah, hello. I'm Nina from Aachen. And I would like to, and I'm here because I'd like to give you some insights on maybe how we can help the world by rethinking our processes. So, oh, wonderful. First of all, I'd like you to maybe step away a bit from ICT at the moment. So we're not talking about processes that run on your computer, but we are talking about interrelated activities that are performed according to certain rules to achieve a specific outcome. What does that mean? So let's just take a practical example. We have a customer, so we have a business process. We're a company. We buy components for bikes, and people can order a bike, and they order a bike according to a specific color with certain components and aspects. So we register customer orders. We then go to our inventory. We get all the items out of the warehouse. We build some of the components. We paint some of them according to the color desired. Then we assemble them and pack them. And then we send out an invoice and get a payment, and it is delivered to our customer. This is the kind of processes we're talking about. So, and what we're looking at is, so these, can you see it? Yeah. These gray boxes, we call them activities. And if we perform a process with regard to a specific customer order, so for example, order ICT4S, we call this activity, an event. So the event where the order ICT4S was registered, and that was one process that happened within one process execution. So what does this have to do with sustainability? So we kind of have, these are businesses, they buy equipment, they sell the products and materials that they produce. We have employees who work there. So actually, at least in Germany, we have 40 hours per week. So we spend about 5 days a week, half of our waking time working at companies, so kind of with regard to business processes. And then we have great environmental impacts. So we have energy consumption, we create greenhouse gas emissions, we use materials and create waste. So these business processes are highly relevant to when we're talking about sustainability. So speaking about sustainability, I would like to talk a bit about the circular economy. So the idea is that we transition from a linear economy to a circular economy. So we transition from like what we consider how we currently live, where we extract raw material from earth, manufacture stuff, assemble final products, and sell them. We use them, and then we just destroy them. We throw it away, we throw it in the bin. And we want to move to a circular economy in which we have different different possibilities to not destroy the value, but retain it instead. So we could say we refuse using certain materials, for example, oil and gas. We can reduce the resources, the materials that we actually use. We can decide to repair and maintain the products we have, reuse or resell something when we no longer need it, refurbish it, so we don't need it anymore, but there has some minor things have to be fixed, like polished again, so we refurbish it, and remanufacture. So individual components are broken, so we kind of disassemble it, change some components, and assemble it. Disassemble and reassemble it again. We can decide to use something for a different purpose than it was originally intended. We can recycle the goods, and we can decide to recover the energy. And finally, if we decided to put something to the dump, we might consider when we find an alternative utilization, we can remine it, so take it back and put it back into our supply chains. So what are our relevant processes in this? So we have processes regarding to the sourcing of materials. We have processes where we manufacture these materials and we assemble them and we distribute them. So we give them, we give them to customers. And we can use, so during our utilization, we can of course maintain and repair things. But then we also need to consider all of the new processes that are not in our current traditional supply chain. So the ones where we take it back from the end user and put it somewhere else. So basically, we need to integrate these new processes into our new system. So what is it that we have to do in general? So we want to increase the efficiency of our processes, but we also want to consider how we can transition the way that we are working at the moment to more sustainable processes. And we want to integrate new processes into the way we currently work. So getting back to our business process, the question is now, how do we do that? And as I already mentioned, I'm from Aachen and I do process mining. So let me tell you about process mining. So the cool thing is that we don't have to model and ask people about how this process works, because the experience in the past has shown that we don't get realistic models if we just ask people and say, so what do you do then? What do you do then? But the cool thing is the activities we use are usually supported by IT systems. So these IT systems log what happens. So they have so-called event data that we can use. So this event data is, so we have such a log is we have an activity, we have a timestamp, we have some sort of objects that is related to, so for example, the customer order. We have, in the case of our example process, we have the resource that the person who performs the activity, we have the components that are used and the package that is created, and of course, we can add some additional attributes about these events. So how much energy did we use? How much carbon did we, how much greenhouse gases, sorry, not only carbon, did we produce? Yeah, so this is event data. Now, process mining. Well, we want to improve processes based on using this event data. And improve is a big word, and it includes a lot, and so does process mining. So we have our real-life processes with the IT systems, and we extract the event data. And as in every data-related topic, this is 80% of the work. So you collect it, you have to make sure that the identifiers are the same from the individual IT system, so it's really a lot of work, actually. But once you have it, you can repeat it. So we have the event data, and then we can automatically create process models. It's these are two examples of process models, a BPMN model at the top and a PetriNet at the bottom. So we usually work with PetriNets. So we put it into an algorithm and get a process model. Then what we use this data, the enriched data and the model, and we do conformance checking. So we see, do the processes that are being performed at the moment, actually, are they compliant with the process that we want to perform? And do we find where are the bottlenecks in my processes? Then we can get some insights, find out, well, what do different things depend on? What are the causalities, rather correlations, but in between different attributes and the processes we can compare different processes that have performed the same outcome in the way that so what is the difference in, say they have the same outcome, but what is the difference in their activity, in their how they are being performed? And of course we take all of this information and we want to act based on that. And there has been a lot of thought of what can we actually do with process mining on sustainability. We can assess sustainability, we could compare different processes, and in regard to their sustainability, we can help decision makers to make the more sustainable choices. But this is very, the descriptions are very unconcrete and very high level. So we were wondering when we read all of this, well, how should we do this? And that's why we performed 2 systematic literature reviews. The first one was just on the very broad area on process mining and sustainable development. And I can tell you, so we organized it into the different pillars. The economic pillar, I think it's pretty self-explanatory why process mining affects the economic pillar. There was a surprise in the social pillar because it's mainly applied to human-centered processes, and there is a branch within process mining that goes into this area a bit stronger called responsible process mining. Then we found out that the environmental pillar is least developed so far. So we took a look at we did a second more targeted review, taking a lot more keywords into account, and we found out, well, the majority of works relates to an increase in efficiency. But just increasing the efficiency isn't enough. Also, we see that they're mainly high-level descriptions, no concrete, how do I actually apply process mining to do that? And state-of-the-art process mining techniques were not really considered. So we concluded that there is no, that the application still requires further research and probably interdisciplinary research. So what we did, we tried to build a little framework saying, okay, if you want to do process mining for sustainability, how would you have to apply it? And we considered what elements of the process do you have to consider, and we built that. We said, what events do you have to take a look at? So what kind of activities? We see that we have to broaden our scope of the activities to look at. And then we thought about what can we actually help with? We can help assess, we can help decide, we can help compare to current standards. And now I'm here and I would like to tell you about process mining and this, and that's why I'm interested in talking to you about this. Do you think this is helpful? Thank you very much for your attention. Sorry for overrunning.
So thank you very much. This was a totally different view. Any questions? Okay. Yeah. Okay. two short questions, sorry, while the next one can start preparing.
Thank you, Adrian Friday, Lancaster University. Not sure I'm that short, but there you are. Interesting work. This is sort of, the process is sort of the how, if I understand it, not the what,
yes,
and not the magnitude. So I wonder, do you think it's important to kind of look at how it relates to the impacts, or is it repeated application of particular steps that makes it very hard downstream to create the recyclability, for example?
Exactly. So that's like processes. That's basically what. So we think that it's not things. We have to consider things in a holistic manner, and that's what we try to do by considering the entire end-to-end process.
Is there a danger this atomizes the problem, so it becomes about very small changes rather than big, important changes?
And so in general, in process science, we see that by doing small steps, you can actually achieve the most.
Okay, thank you.
These have been already two, but okay, a quick one. Yeah.
Hello, Laurent Brun. I will take the hypothesis that to have this implemented, you need to have strong interaction between engineers and system designer. And naturally, you converge to monopolies. Either you have on the monopoly is a very simple solution for that. So, and even if you don't implement a monopoly, at the end, if you want all the full process to behave correctly, you can frame it in a way that at the end it's a monopoly. But monopolies are totally forbidden in Europe. So at some point, if you implement it well, you will set up monopolies that will be in contradiction with treaties. So why should we not just implement monopolies in a large domains like energy, food production, or so question about monopolies, Maxime.
I'm not really sure I know too much about monopolies and what to answer about this. I don't really.
Just
maybe
a simple
I didn't
example.
understand the question.
Perhaps it's not a shorter question, but you need interaction between engineers. If you want to repair something, you have to know all the details about the machine.
Yes.
You need to know all the details. On to do this, you have people producing, share everything with people recycling. At all levels of your pyramid, you need strong interaction between everyone. If you need this kind of interaction, things need to be totally public. And you need exchange, basically. You need to have engineers really work with each other. And so you need to some people designing stuff, thinking how to design in a way they can be recycled. So only monopolies can implement that. And monopoly is also a simple implementation of that. This is my question.
I would say that you can also argue that you can send your products back to the company that you bought it from, and the people that you actually have to integrate the new processes into the existing system.
Okay, sorry, I have to cut it now. We are already late from the start, so I'm not saying much. Just from Orange Lab, uncovering the environmental impact of the software lifecycle. Have fun.
Yeah, I can. Okay, this is working now, I guess. Okay, so good morning. I'm Thibaut Simon, and I'm a PhD student at INRIA Lille in the Spirals team, and I'm also employed by Orange Labs, which is the building at the next metro station. And today I present to you the work we did on software lifecycle environmental footprint together with my PhD advisor Pierre Rust, which is here, and Romain Rouvois, as well as Joël Penoa, which is a colleague from Orange Labs. So ICT environmental footprint, I give you a few non-exhaustive list of these impacts because it has been said already before here. But basically, GHG emissions have been talked about a lot, including their consequences this morning. But what I would say is that the sectors, even if it grows or not, is not really aligned with the Paris Agreement that was talked this morning, and the current trajectory is not the right one. Now, ICT also require rare earth materials, which extraction harms the local population as well as the environment. Now, finally, on ICT environmental footprint, while ICT devices end their life, they become e-waste, which a small part really is collected, and even a smaller part is very recycled, and it often ends like this. So what I would argue is that while the ICT environmental footprint comes from the hardware side, the responsibility lies within the software, because software makes hardware run and use energy. It is software that consume more and more hardware resources for even more needs. And finally, part of the e-waste that I shown before is driven by software. So what I did is that I wanted to see how the literature as well as standards consider this software environmental footprint. And what I found is that, well, it mainly focuses on a single impact categories, climate change, through GHG emissions. It's often considers only the energy which is consumed by resources, by hardware resources, and omitting their embodied impact, which is due to their manufacturing as well as end of life. And finally, the standards of literature often focus only on the software usage phase when it is used on, but they often omit the development phase of software. So to tackle these lacks, I used the benefits of a life cycle approach, which is basically, I'm sure that most of you are familiar with this, but a life cycle analysis basically and simply is the analysis of the contribution to the environmental impact of a product across its complete life cycle, ranging from manufacturing, usage, and end of life, and other phases across multiple impact categories. Now, there are two benefits. There are more than this, but there are two benefits of using such a holistic approach. That is to identify the shifting of potential environmental burden across two things. The first one is between phases. Now, think about electric car, for example. If you replace your petrol-powered car by an electric one, then the usage phase, at least in France, will reduce, but the manufacturing as well as material extraction phase impact will increase. Now, another kind of shifting that can happen are between impact categories, such as, for example, if you switch your energy generation from a coal power plant to solar-based one, then you will probably reduce your climate change impact while increasing water depletion or raw materials impact due to the manufacturing of these solar panels. Now, what we did is that we wanted to see what kind of outputs we can have by using such a holistic approach on software. So quickly, what we wanted to do was to find a flexible way to adapt to each software context, because software are very different from one another, their life cycle are very different, and we wanted to find a flexible, while simple way to model this software life cycle. So basically what we did is that we used a tree representation where each node of the tree represents an activity, phases, we call it how we want, if you want to match the LCA vocabulary or not, if you want to adapt a little bit, that it's possible. Now, the idea was to keep a common computation methodology despite the variety of life cycle. And we consider that to be achieved, each of these phases or activities needs resources to be achieved. So for software, the first resources that we think about are hardware resources. They are virtual machines, they are servers, they are storage, etc. But there are also some other resources typologies that are consumed while developing software. And here I show that, for example, the people that work on this software have an associated environmental impact. And what we did is that we gathered an exhaustive typology of resources and their associated impact that can occur during software environmental, the software footprint, software life cycle. Sorry. And for each of these resources that we gather the impact, we gather the impact on multiple categories because, as I said at the beginning, climate change isn't the only impact of ICT. And quickly, what this shows here is that, for example, if you take the impact of one people that comes to work from one day, then these people will use other resources such as a laptop, monitor, an office which uses electricity, but it will come to work using his car, public transport, etc. So these resources uses themselves other resources. And so using this way, what we can do basically is that we can compute each phase or activity relative impact thanks to the resources that they consume, and then we can obtain the overall life cycle impact at the very top of the tree. Now, I said earlier that the benefits of such an approach is to uncover impact shifts, and to apply this methodology, what we did is that we took data from the GitLab project, open source project, as this will not be the footprint of GitLab, but rather representative of its size and complexity. And what we did is that we applied a post-mortem approach using COCOMO, which is a methodology to estimate the effort which is required to build software, to estimate the effort that was required for the building phase of GitLab. And for the usage phase, we used the hardware requirements for the biggest instance possible. And we used the factors that correspond to hosting and development in France. And now quickly, because I ran a little bit out of time, but the kind of shift that we can see here, the idea is to look at orders of magnitude rather than absolute value due to the imprecision of reference data. But basically, we can see here that on our sampled use case, well, the build phase is a very large part of the impact, and it's largely is more than the running phase one, which we would not have seen if we did not take a lifecycle approach on software. The second one is between resources. We can see here we changed the thing because I think we can all agree that software cannot really be GitLab will software this side will be hosted simultaneously on multiple sites. So its usage impact will be much bigger. So what we did is that we evened the build and run impact at the tipping point where the build impact is at 50% and the run impact is at 50%. And what we see here is that using a holistic typology of resources show that, for example, on the overall software footprint, the car impact is really there and really important, which can be a little tricky. Now, the other thing to see here is that for storage, for example, without considering its manufacturing impact, we could not actually have seen it as a big source of impact due to its low usage, energy consumption, but rather big manufacturing impact. So I will just skip this one, but the idea is basically do not focus on CO2, consider the other impact categories. We proposed a web application that will soon be available open source on the Orange repository, but is going on bureaucracy things right now. But it allows each and everyone to model their own context, because all the things that I presented here are already dependent of the context and they are not generalizable. So finally, to conclude quickly, what we did is that we developed a methodology and the associated to model a software lifecycle environmental impact. And the idea is to identify shifts as well as hotspots to take the right decisions to reduce this software environmental footprint. And the last key idea is that it was hard to gather resources. They are imprecise, they are average, they are not really good, and the ecosystem pretty much lacked the data on the resources it uses. So thank you very much for your attention.
Thank you very much for this insightful presentation. Any, yes, a question? Okay, one, that's great.
Thank you. Thank you. I'm François Tajani from Rennes. Thanks for this great presentation. I've got one of your later slides. There cars were appearing as a big chunk of, yes, I think it was here, yes, as a big chunk of the overall impact. And it's a bit striking because we're speaking of software and we see cars appearing. And do you think it means that software engineers should be required to cycle to work as soon as they work on software? Or what is your thought on that?
Well, basically the idea is to show that if we consider software in a more holistic point that we do right now, considering only the usage, so show the importance, for example, of the businesses' policies on their employees commuting, and this really shows on the final product, which is not really said before, I guess.
Thank you. One last question for Adrian, but in the meantime, please, Francis, Ian, Nina, come up to the panel.
Hi,
And Francis.
thank you for the presentation. That's really interesting work. So I think I buy the idea of a more holistic approach generally. There's a couple of other ways it strikes me that software has impact. One is the sort of, if you do this on the toolkits that you're then using to build your software, there's sort of some embedded effort in creating that. So what you choose to build it with probably has a sort of hidden factor. But the other one that probably interests me more is what happens when it gets deployed and the impact engineering the software has, you know, on its long-term longevity or its embedding of things like machine learning or video transcoding or whatever. Do you think there's a way of adapting this to think about what the future implications of the software are?
Well, it's complicated to, if I understand the question correctly, it's complicated for software that is already used to use such an approach, because being holistic is quite useful to see these hidden impacts, but to gather the required data is really hard. And if you use software that is developed from someone else, then you won't know really how much it costs to be built. You will only sometimes know how much it costs to be hosted, but that kind of...
So should we have a manifest with it so that when you use it, you know not to re-engineer it because it already has, you know, a lot of effort in it?
Yeah. If you reuse software rather than rebuild it, you will remove a vast majority of impact in some cases. It depends on the cases, but
Thank you very much.
Thank you, Adrian. Thank you, Thibaut. Please take your place here. You can leave this. Thank you. So no. You have. You need something to drink. Understandable. Okay. When I was looking through the papers presented in this session, it came to my mind that they were all basically about decision making, supporting decision making, right? On a very individual level, on the Tech for Bad, on an organizational level, process mining paper and the LCA paper, on a more political level regarding the input and output analysis. And I'm actually wondering, how far are we as researchers in IC2RS should go, can go, with regard to supporting decision making? Are we putting out our papers, that's it, fine, you know, we did our studies, up to the politicians? Should we go further, right? Saying, pushing in education, in company, on politics, you know, this is what we found out, we are doomed, do this, do this, do this, and please follow the strategy. Or should we go even more one step further and say, this is the only chance you have to survive, you have to do that? And the question following up, are we then still, if we do that, you know, where are we? Are we researchers? Are we activists? Are we somewhere in between? Are we none? So this is my questions I raised to the panel, but also to the audience. Whoever wants to start.
It's a very profound question, isn't it? We all have multiple identities, different roles in our community as researchers. Yes, indeed, different hats. Yeah. And it gets uncomfortable if we wear too many of them at once. But, and of us here, we don't all have to be following the same pattern. I would like to be more politically engaged. As a researcher, I recognize that if I go and ask questions of lots of people in ICT and oil and gas, just the very act of asking questions and helping them to think about it is going to make a change. So it's hard to separate You can't stand back and be, in the sense, a pure researcher like a physicist.
Thank you.
So I see myself as a researcher, as a person who should provide the tools to be able to make the right decision. But I see my role as a human to be a person who should drive people to make the right decisions. So I think it's an overlap between me as a researcher and me as a human being that wants to make the world a better place.
So I like the idea of being an activist. That's my activist hat. And so, but when I want to engage, then I realize, because of the complexity of all the interrelations between activities and the society, that it's not so simple. So if you decide to say you have to do that, then there will be lots of consequences, some that are not desirable. So that's why I prefer to have a more, this hat, a more modest hat, and to engage into this kind of position. Only, for instance, there's one thing I'm very sure about. You have to reduce speed on French motorways to 110. That has to be done right now. And but even when I say that, I wonder, will this impact, the production of cars? So this is more, and will this cause some unemployment? So it's really tricky.
Well, I do pretty agree with Nina that we need, as researchers, to provide the tool to model and explain what we want to say. As I said in my presentation, the ecosystem pretty much in software lacks the data on the environmental footprint of resources it uses. So when people in software want to model their project impact, because we say to them that, okay, you can maybe think about that, what you do have an environmental impact, and try to model it, and then we say, okay, data is not really available, it's hard to say, so, and it is complicated, because for me, decision process rely on data, and if people outside of the research community does not have access to reliable data, then they can really adapt their decisions and take the right ones.
Thank you. There are a couple of hands up there. So I don't know who was first. I have no idea. Just give it to someone next to you.
Hi. So I really liked your question as well. My name is Anna Oprescu. I'm from the University of Amsterdam. I really liked your question as well because it appeals to the many aspects. As a researcher, I believe in producing mechanisms for society and not imposing them. But then as a mother of a 2-year-old, I really think about the 7 generations, to touch on last night's performance as well. My question is, though, how far are we from actually standardizing the methodologies that we offer to the society to create these policies and to allow to give them the means to create policies that take us further? So I think standardization would also maybe touch on the monopoly question that was raised earlier for the process mining. So thank you.
Okay, there were other hands up. I think Vlad or. Okay. Yeah.
Hi. Okay, it's cool that you take my question because it's not a question, because you asked your question to the audience. So I think my take on that question would be that I think it is indeed very strong when a scientist go into activism, or at least step back and feel the urge to adopt a new hat. For example, we saw that with some IPCC researchers that engage into scientist rebellion or stuff like that. But also, I think that it's also really interesting that we keep also some scientists that remain neutral to also keep this like a way of convincing other people that can be doubting about those things, but still believe in science and the scientific, and that we don't lose, that we are not accused of, having a political agenda in mind. So I think that both are interesting and useful.
Thank you. It was up there, I think Vlad, and then behind Vlad, and then you. I have you in mind.
My question is specific to Ian, so if you want to wrap this up first, then I wait.
Okay, anyone else wants to add to the discussion we had here? Yeah, okay, there was this and you, and then Ruza.
I think it's a point in the discussion where it would be really nice to have someone from, this science and technology studies speaking, right? This discussion about the neutrality or the non-neutrality of science, that's something that's going to keep bugging us if we don't organize a session where we specifically address that and not just amongst computer scientists.
Good suggestion, thanks.
Definitely agree with that one.
Ruza, and then...
So, Daniela from Technical University of Munich. So I have a more practical question about the methodology. For example, the last presentation we had about software, how to set the system boundaries, because, there is a different scope, right? If you communicate the results and a large share is caused by the workforce, for example, then for the decision maker, it might be a bit blurry. Like, is it more like a corporate thing, like to reduce or set incentives for more sustainable transport to commute to work, or is it really something in the software itself? So it's more a question about what do we report on scope 1 to 3 emissions for a corporate of an institute, and then what is the impact of the product itself?
Well, I guess it's more of a point of view is that at any level, if I'm reporting on my company emissions, if I assess them, or if I develop software from a day-to-day basis. And what I personally think is that apart from reporting, what we should focus on is that, okay, how can I lower what I do on my part, even if it's coming by other means of transport, if it's by my work as a software engineer or working on other sectors. And what we should all do is that for the responsibility that we had, we should see and assess how we can act at our level to reduce the emissions. And I don't know if it's a response really to your questions, but
thanks.
That's my take on it.
Thanks. Ruza, and then you.
I'm not sure if we have already finished the previous thing, but I wanted to just kind of make a point. Mael, I think the time has passed. There is no more time to be neutral and sitting on the fence. We have to act. If we know something is right or wrong, we need to act according to that. That's my point. I mean, there isn't any more time to be neutral. But on the other hand, what we are doing in our practice, in our daily life, it's actually what we preach others to do. Why should anybody else do what we are telling them to do without doing it? So unless we do it, why should anybody else believe us to be worthy to kind of listen to? And from academic perspective, we do the research which we need to put in practice. I'm not telling that, go practice something that you don't understand, but if you know something is right and you're trying to convince others to do that, why don't you do it yourself? And from practice perspective, there is a lot that we learn from practice that comes back to academic life, so it's actually mutually beneficial. So I do think that as practitioners and academics, we are both, and we are benefiting from both, and we are helping others to benefit from our knowledge and expertise best way.
Thanks, Ruza. That was more a statement, not so much a question.
I would just would like to say that, yeah, we have to act now, and we had to act yesterday. And but it's one thing acting, believing that this is what you have to do, but you have to evaluate. Actually, lots of people say you have to evaluate what the actions that you put the policies, and I think we can speak about that. And are these evaluations of policies right? And can we help in showing the positive effect, but also maybe the problems with the policies that are enacted?
Thanks. There was another from Adrian.
Hello, Adrian from Ernest de Lyon. A more general question to the panel. Thank you for our presentation. I also make my PhD thesis on assessment, impact assessment of ICT. And the general naive question I want to ask you is what to do with this? What do you want to do with the assessment of your environmental impact? Does it is for pointing out where the impact is, or for example, making activism, or in other case, for example, are you interested in environmental accounting, for example, does it influence your research or not?
I'll start in that I'm transitioning from being a management consultant to being an academic. My last IBM role was as their sustainability leader at the Department of Environment in the UK, a big IT outsourcing, and we wanted to use this sort of work to make a change to the IT footprint. We did LCA assessment of software projects and found that the development phase was by much the largest, and we made changes. As simple as a decision not to fly someone over from the US, but to do it by video conferencing. Now that sounds obvious now, but that's what we were looking at 10 years ago. So yeah, it's about changing the way that we operate in an informed way.
Okay, Vlad.
Yeah, it's to you, Ian, again. Hi, thanks, and many thanks for your wonderful talk. To also position myself, I believe that technology and logistically supported energy transition is essential and perhaps more important even than behavioral. And this is not to deny the importance of the latter, but thinking of yellow vests in France or the Bangladeshi parent trying to feed their kids, I think it's unrealistical and to some extent immoral. So I think that the energy transition is at least as important. And in my paradigm, an argument could be made that Shell and BPs of this world are the best positioned to swap the petrol in their tanks with, for example, green hydrogen. And they would actually could be crucial to do this very fast. So would you agree to my point? And if yes, do you see a conflict with your normative point and any way of addressing it?
I agree that the energy transition is absolutely vital. We need the demand side to make sure that people have attractive, cheap, available options for electric mobility, electric heating, and that's absolutely vital. I think we are not providing enough policy attention to the supply side. And that's what concerns me. We need, yes, to get people to move across, but also to stop fossil fuel extraction and burning. I agree that Shell and BP have the skills that make them important players in the transition. And I use as a teaching example Ørsted, which used to be Dong, the Danish oil and national gas business, and is now one of the largest renewable energy players in the world. So it is possible, but Shell and BP are not moving fast enough, not putting enough of their investment into renewables, to the point at which significant investors are now saying, these climate plans are not good enough, we're going to take our investment money away and move it to some other businesses that are showing more commitment to the change. I think our positions are complementary. We need both demand change and impact on supply. And I'm increasingly fascinated by the comparison to the transatlantic slave trade. And you ended up with the British Navy having a naval squadron on the Africa coast for 60 years, intercepting slave ships. In an extreme situation, could we imagine navies of the world intercepting oil tankers?
But we also have Gorbachev, and I'm rather happy he didn't leave the Soviet party in '75.
Okay, thanks. What to say next? I think there were two more questions, and then we are stopping this rather interesting discussion going in lots of different directions. Yeah.
May I take one here? Yeah, thank you. So it's Thibaut from UC Louvain. Thanks a lot for your very interesting presentation as well. I have a question related to what the other Thibaut said. I think when you mentioned the LCA as a tool to that could be used to identify and then improve the different products, and I'm also doing LCA myself, so partially and agreeing with you. But then we had, I think, that issue with applying LCA on everything with like a product-oriented view is that we can improve the products and get to a level where it's better than before. But as paper showed in the past, this is not sufficient to answer the question, is it good enough? And also, how does this tackle the general question to reduce globally, not just for one product? So this could maybe linked a little bit with your presentation, Francis, which is more at a macro scale, but still focus on the ICT. And so my question would be, in your opinion, how could LCA be used or integrated in something that could help towards a global decrease and not just focusing on products, feeling that they are getting better, but then not tackling the general question of decreasing general impacts?
Okay, so thanks for your questions, and you have a really nice name.
You too.
What I would say is, obviously, LCAs are their limits, and they are not perfect. But I mean, nothing is perfect. And sure, what I would say is that macro change are required, but they have to come from, for me at least, from both sides. They have to come from structural changes as well as from the people. So if people want to act at their level, which is more macro scale on a single project, etc., they need to have the tool and not only the tool, but the data to take the right source decision. And I think that in this aspect, LCA can help, but yeah, it's not enough, obviously, but I'll say that it is better than nothing, and yeah.
Sure.
Thank you. There was one last question from Helmut. Sorry. Sorry.
Thank you.
I think there was a question for myself. Can there be from Thibaut? The idea is that you can perfectly, the models are the same, so you can hybrid, you can have a hybrid model with some exchanges model as input-output and some other using LCA results. And so you can, it's very flexible, see, and you can mix both approaches, in my opinion.
Okay, I'll be very brief. Stephanie Kunkel from Helmholtz Center Potsdam. I just wanted to support the value argument because I think one thing I read, which I found very convincing, if it wasn't for the value of sustainability, what would be the reason of existence for sustainability studies in the first place? And one just comment on the idea of value in science. There's a lot of research, and we have thought about it for a bit at our institute, about the transformative science and transformation science and transdisciplinary science. And I think this literature is very rich and provides a lot of insights how researchers can position themselves in this value and mission-driven process. So it's quite interesting if anyone's interested, so have a look.
Thank you. I think this is a nice last statement. Thank you all very much. An applause for the panel. It was very insightful answers, and we learned a lot about process mining, the insights of oil and gas industry, and assessment. And I also think it might be nice to have at the next ICT4S conference maybe a session dedicated to this. With I also know an SDS researcher. We might talk about it, and then over to Benoit.
Thank you very much. I'm very sorry, just a very short but important information for tonight, for the gala. We just heard this morning that there is the cycling race tonight downtown in between 8 p.m. and midnight. So probably the easier way for you is to arrive just before 8 and to not leave the gala before midnight. Otherwise, there is other opportunity for you. There is no trouble on the metro. And so the address of the gala is on the website, and you will see it's not so far from the train station. And at the train station, there is a metro station for lane A and B. So whatever you are close to the metro, you should be able to reach the train station and then to walk 10 minutes to the gala place. Otherwise, there is also buses, but with a lot of deviation because they try to avoid the place where the race is. And there is a lot of temporarily the bus stop. So please look at the website of the company of Bus of Rennes if you want to take the bus. Otherwise, take the metro, and otherwise arrive before 8 and leave after midnight. Thank you very much.
Now enjoy the break.
Yeah, no problem.
Thank you.